Hi, y'all. It's Wednesday, and we are not in school, which is a total shock to me. But it's great news because we get to make one more video. Actually, I just go ahead and mention this. If we don't have, if we don't have school tomorrow, what I'm actually gonna do is, so tomorrow will be day 4 of the unit. A couple of years ago, we didn't have school on day 4 of the unit, so I actually already have a video from 2 years ago for tomorrow. So if we're not here Wednesday, what I'll do is maybe just do like a post quickly, like relinking that video. It'll be a little bit weird. Like, I won't be talking to you. I'll be talking to students from 2 years ago. So it won't perfectly line up, but the key knowledge will be in there. All right, my camera's being funky, so let's do our agenda and get to it. I'm going to try to go faster than yesterday. Yesterday was too slow, for sure. Okay. Hey, y'all. Here's what I'd actually like you to do, and this might actually be faster than you sitting through the whole video. And it's certainly, if possible, a better way to go about the assignment. Hey, get a calculator and maybe consider just doing the Wednesday worksheet first. In theory, this would be something you worked on at the beginning of class before class started. So if you really did like buckle down and watch Monday and watch Tuesday and are kind of picking up what we're going over, you could, in theory, at least, you could definitely read the Wednesday worksheet. You could definitely try the Wednesday worksheet, and you might even be able to do most of the Wednesday worksheet correctly. And if you think you did, just skip ahead to the answer videos. Just fast forward, click on the little time bar at the bottom, and just kind of do the worksheet, check the answers, and you'll be good. What I would say is I'm going to try to go faster in general. Hey, the last 2 minutes, I do want you to stop. So if you're going to fast forward and... By the way, you're not supposed to fast forward and write down the answers. You're supposed to do the worksheet, fast forward, and check your answers. There's a big difference. Don't let me down. But do watch the last couple of minutes where we're going to preview Thursday's class. And then, hey, yes, do the bookwork. So what I'm basically checking for this lesson is, did you do the bookwork? If you don't have your textbook for some reason, maybe a friend can... text you a picture, or I'm also, when I go into school this afternoon, I'm going to photocopy the page and put it online. I don't currently have a copy of the book with me. Yeah, that's the plan, Stan. And I will also, hey, just a quick recap of, since we've been gone 3 days, what do I want to see tomorrow? I want to see today's assignment. We are going to have that pop quiz where we are no longer in the divide business. We're now in the multiply business. We're no longer in the slope business. We're now in the area business. We're no longer in the rate of change business. We're in the total change business. And we're no longer in the derivatives business because we are in the integration, or we are in the integrals business. So definitely that. Definitely the bookwork. And also, did you do that specific drawing that I asked for? On the day 2 assignment, which was RAM n equals 6 for the turkey graph. Those are kind of the 3 things I'm looking for. All right, so definitely do the bookwork. That's number 1 thing, because if you do the bookwork and you do it at least somewhat correctly, I feel like you've learned what you needed to learn in the last 3 days. All right, I can use area to find total change in context. So we're going to be talking about the meaning of area some more. That's maybe our big theme this week. And then our big technique this week is estimate area using rectangle approximations. And then this last one is just kind of a preview of tomorrow, that we can describe the value of the exact area as the sum of an infinite number of infinitesimally small rectangles whose width approaches 0 and whose heights are determined by f of x. All right, don't worry about that right now. We're in the total change business, and we are in the area business, and that's what we're going to do. All right, so here's how we're going to do the assignment. We are just going to skim the front, and I'm actually going to start on the back page to reinforce this idea of rectangle approximations. So question 1 is something you can do on your own. I want to see you try it. I'll put up the answers later, but you should be able to read this and at least make an attempt at a solution for the total amount of snowfall. So in other words, you're looking for total inches. Hey, if this is inches per hour and this is hours, what would be the inches in this picture? I'll give you a hint. What would be the inches? All right, figure that out. And then here for question 2, if you've already done question 2, that's fine. We are going to kind of tackle it in reverse order. So according to the website Barometer Syndication, snow will fall at a rate modeled by S of x equals sine of pi over 4x plus 2. S of x is inches per hour and x is hours. The model also predicts snow will fall at 8 p.m. but only lasts 6 hours. So we are going to be treating that as like from 0 to 6. 8 p.m. is t equals 0, and then 6 hours later will be t equals 6. All right, and then here's what we're going to do today. We are going to practice LRAM and RAM estimates. We're going to use n equals 4, so we're going to use 4 rectangles, and this is the order that we're going to do things. We're going to determine delta of x, the width of each of the 4 rectangles. We're going to enter S of x into our y1 in our calculator, and then we're going to complete the table below using the table screen in our calculator. All right. And then we're going to draw markings on top of the table that represent each of the 4 rectangles. All right. Let's, on the back page, maybe do some rough drafts of what all this means, and then we're going to go back to the front page and just fill in the answers. All right. Here we go. By the way, hey, there's that bookwork. This is required assignments. Make sure you're looking at the instructions. The book asks you to do upper and lower sums. I don't want you to do that. I want you to do left sums and right sums. So in other words, the process that we go through today, that's the process I want you to use for the bookwork. I'm changing the instructions, but I think these question numbers are still all good. Okay. So we are supposed to figure out an estimate for the area under this curve because that'll represent the total amount of snowfall. And I believe the first thing we had to do was find delta x. So delta x is our rectangle width. And I think yesterday we had a formula for delta of x is b minus a divided by n. And this is actually really just a common sense idea. What this formula is really just asking us to do is say, hey, look, from A to B is 6 total units. 0 to 6 is 6 blocks. If you're going to use 4 rectangles, how wide is each rectangle? So our B minus A is 6. Our N is 4. All this is really telling us is that each rectangle has to be it's going to be 1.5 units wide. That's all that means. Right? 4 rectangles, 6 units to work with, 1.5 each. All right. Here's what I'd like to do in order to make sure at home we're processing what an LRAM or a left rectangle is. I'm going to draw the rectangle. And what I want you to do is just in your head work out when I should stop the rectangle. So I'm going to start at the bottom. We know that first rectangle is going to be 1.5 units wide. And it's going to have a height. And in your mind, if we're doing left rectangles, I want you in your mind to say like the word stop when I should stop. All right. I went all the way up. I went too far. Hopefully in your mind, you said stop right now. Because if we look at our rectangle, the left edge of the rectangle has intersected the y value of the function. So that's a left rectangle. All right, let's do it again. I'll go a little bit quicker, but I still want you kind of doing this in your head. Let me be a little more. There we go. All right. So our next is still 1.5 units wide, so from 1.5 to 3. And you should be saying stop when we've drawn a left rectangle. All right, hopefully you said stop right there. Because our left edge of our graph doesn't really matter where the right edge is. What the right edge is doing is irrelevant. If we're doing a left rectangle, it's when does the left edge hit the function, or for what x value on the left edge do you get a y value on the function. All right, we have 2 more to draw. So we're going up, we're going up, we're going up, we're going up. We don't care about this. No. We're looking for that left edge. Boom, there it is. And I tell you what, let's fill it in a little bit better. All right, there's our left edge rectangle. And then our last one is from 0.5 to 6. We don't care about that. We care about that. Okay. And this is our left rectangle sum. What we need to know is how big each rectangle is, and each rectangle is going to be the base times the height. This is where that thing in your calculator comes in. So in our calculator, what we can do is use our table to kind of help us out. Let me move this over here. Clean up the area. So I've got the function graph, and I've got the window set up, and let's not worry about that for the moment. What we really just care about is, okay, in our table setup, we know we want to start at 0, and we know we want each rectangle to be 1.5 units wide. So that's our delta, right? Our delta x, or our delta for our table, is 1.5. What the table screen is going to show us is all of the y values that we need. That first rectangle has a height of 2, and we knew that just by looking at the graph. But that next rectangle at 1.5, the y value of the function is 2.924. So that tells us that height. The height at 3 is going to be 2.707, and the height at 4.5 is going to be 1.6173. Right. And for the homework, I really want to encourage you to figure out, hey, what's the delta x? Type the function in your calculator and use that to determine the heights that you need. I really don't mind you using that. I think that's a really effective just way of organizing the work and saving time, instead of having to literally type in like sine pi over x 4.5 plus 2 equals, and then having to do it over and over and over. Okay. Here's what I'd like you to do. At the bottom of the page, I want you to draw the right rectangle triangles. So it's a little bit different. If you remember, the rules are the right edge must intersect the function. So I'm not going to draw the final thing. I'm just going to let you kind of do the mental exercise. When does the right edge intersect that function, right? That's left edge, right? Think about how to draw that rectangle so the right edge is intersecting the graph. And do that for every value. So I want 4 total rectangles all the way across. Each rectangle's height is equal to the function's value at the right edge of the rectangle. All right. I think I'll put up the answers in a little bit, but I want you to just try to do that and try to draw it out. Okay. What we're going to do is go back and finish the first page where we're actually coming up with the area of, let's see if I can do it. We're actually coming up with the area of these 4 black rectangles, and we're going to be using our calculator. And at this point, I'm just going to switch over to the answer key, and you're going to be able to check your work for the first page. Okay, here's my answer key, including question 1. So if you have inches per hour and hours, when you multiply them, what you get is the total inches. So determine the total amount of snowfall in inches. The area of all this is 12, so it's 12 inches. And there's more than one way to work out the areas. It's fine just to split it up however you want. So this was just the easiest way for me to divide up the inside so that I could work out the total areas. You did not necessarily have to chop it up like I chopped it up. There's some different ways to cut it up. As long as you got 12 inches total as the area, we're good. Okay. This is kind of how our work should have looked for the first page. So in our table, once we know our delta x is 1.5 and we start at 0 and we end at 6, I don't know if y'all remember this yesterday, but your columns, your number of columns is always equal to n plus 2. So that's how I made this worksheet. I knew since n was 4, I should put 1, 2, 3, 4, 5, 6 columns. There's no deep meaning to that. That's just kind of how tables work in terms of organizing. So 0 to 1.5 is that first rectangle. The next rectangle exists from 1.5 to 3. And just so y'all know, most of the time we don't ever actually draw the graph. We make a table, and these little rectangles, this is like our metaphor for the rectangle, these little marks at the top. So 0 to 1.5 with a height of 2. 1.5 to 3 with a height of 2.924. That's the second rectangle. 3.5 to 4.5. So it's always 1.5 for the width. 2.707 for the height. And then our last one, if we're doing a left rectangle, we would be using a height of 1.617. Down here, I actually did the LRAM and RRAMs. And this is that version where we factored everything out. So if it's 2 times 1.5 plus 2.94 times 1.5, 1.5 is a common factor, so I factored out 1.5. I don't remember if that's in the instructions or not, but that's a thing. If you didn't do that, as long as you got the total, that's fine. And I also did the right rectangles. So the first right rectangle doesn't have a height of 2. The first right rectangle would have a height of 2.924 because it's the right edge of that first rectangle. The second rectangle would have a height of 2.707. And what always ends up happening is you use most of these values, but for a left sum, you never use the last value. For a right sum, you never use the first value. That's just how it works out. And then I average my answers to create a third approximation. That's kind of a preview topic. We'll talk more about that when we get back. And then the last question on this page was, do you remember how to determine the exact value for the predicted snowfall by using the long ignored button on your Calc menu? So I do think this year we've talked about this. I use it to determine the approximation that was the closest. So let's take a look in our calculator. We have the function graphed. And if we want the actual area of the space, our calculator can tell us. We've estimated that it's kind of somewhere around 13. So somewhere around 13 total inches. Hey, just so you know, I've just basically typed my window in the same as the window on the back. -1 to 7, deltas of 0.5. And then the X min and X max is a little bit different just because the shape of the screen is a little different. But let's go second trace 7. That's our area button. Our lower limit is 0. So where does the area start? And our upper limit is going to be 6. So we're going to hit 6 enter because that's where the area ends. And it's going to fill in all that space. Gosh, it feels great. It's just the best sensation in the world. And what we get is that 13.273. Hang on, I'm plugging in my computer because I don't know if anybody else is having anxiety about 18%, but I sure am. All right. But that's what that does. Hey, I think at this point we've basically covered what we need to cover. In the book work, what you're going to do is type each function in. You're going to work out delta x. You're going to work out delta x by doing b minus a. So the last like 6 minus 0, divide by the number, and use that to make a table. I really want to see y'all make the tables. And just honestly, the reason is on the AP test, usually we're analyzing tables to do the sums. We're not like given a function and sketching a graph. It's more that we are given the table. The table is presented to us, and we're just asked to work out the estimate values. So I just want us very comfortable using table presentation. So do your work as a table. And then that's it. Don't forget what's on the pop quiz tomorrow. I want to know what business we're in now that we're no longer in the derivative business. I want to see the bookwork, and I want to see the turkey problem on day 2 with a right rectangle sum and n equal to 6. Those are the things. All right, hey, let's do a little preview of what we're going to learn tomorrow. And it's based on kind of turning our work into the calculator work. So let's see if I can get my rectangles back up here. Gosh, I'm a wizard. This is not this shape. These 4 rectangles put together don't really capture the nuance of the actual area. So how do we turn our work here into the work of the calculator, and how do we turn the values we get for the estimates into the actual values. And that's what we're going to talk more about tomorrow. And I don't think it's going to be a total mystery. So let's check your work for the right rectangle. So at the bottom of the page, I wanted you to draw out your 4 right rectangles. It should have looked something like this. This number is slightly off, and just the reason it's slightly off is I can only drag this, so I haven't dragged it to exactly 6. It's kind of close to 6, but not quite. So that's what's up with that. You can kind of, this value should be close, but it's not going to be perfect. All right, this was your right sum, or this was our left sum. Well, at n equals 4, our left sum doesn't really kind of fill the space very well, but if we raise it to say n equals 8, what we find is, oh, the thinner the rectangle, the more kind of space the rectangle can occupy, or the thinner the rectangle, the less kind of extra space we have hanging. So we could do n equals 8. We'd have a delta x of 0.75. We'd make our table. It'd have 10 columns. And we get a number that is a lot closer to the actual area, right? That actual area was like 13.2. But if we wanted to get even closer, we might do something like n equals 20. Hey, now that n equals 20 and we have these 20 rectangles filled in, look at how good of an estimate we're getting, because we're managing to fill up kind of so many of the nooks and crannies of this graph. And look, the work would be tedious, but we know how to find the area of a rectangle. We know how to use our calculator to figure out f of x and get the y value for all these points. All we would do is just base times height, add up those 20 base times heights, and get a number. So the work wouldn't be difficult. It would be tedious, but it would be very simple to do, right? If you know the area of a rectangle, anybody can do this. What would be really tedious is n equals 50. But if n equals 50, we get an answer that's actually a really good estimate, right? The difference now between 13.323 and 13.273, right? We are so close. We're in like, what is it? We're within 0.5 compared to where we started. Well, what does the calculator do? The calculator takes the limit as n approaches infinity. So as n approaches infinity, well, obviously, we're going to have an infinite number of rectangles. And our delta x isn't growing, it's shrinking. So if our number grows forever, our width of each rectangle shrinks forever. And I guess at some point, we're going to have to add up an infinite number of infinitely kind of small values. Because at some point, you're going to have like 0 times the height, or you're going to have virtually 0 times the height. So your area of an individual rectangle is virtually 0. So the calculator adds up an infinite number of infinitesimally small values, and it gets, you know, it gets this value. And that's kind of what we're going to learn to do maybe after Christmas. Before Christmas, we're just going to kind of talk about the meaning of area and ways of estimating area and the reason we study area. After the holiday break, what we will do is learn how to add up an infinite number of infinitesimally small things. It doesn't take very long. It actually, I would say, working out the exact area by doing that would take less time than, say, n equals 20. You don't actually have to write out like an infinite number of numbers. There are shortcuts, there are tricks, just like we learned some tricks for derivatives. Like we learned the power rule trick so that we didn't have to work out those limits every time. We're gonna learn some shortcuts. Okay. I'll see you tomorrow. I really want to see you do the bookwork. I've covered how to do the bookwork, right? We are in the business of taking a graph and estimating its area by filling it with rectangles. I wish I hadn't used such a large number. But you can do the bookwork. I want you to do a left sum and a right sum. I want you to write your work as tables. I want you to check your work with the calculator. So type in the function 2y equals and press second trace 7. All right, here we go. We're coming back. Coming back from infinity, or at least back from 300. Yeah. So I'm hoping the bookwork is going to look something like this. You've taken a graph, You figured out how many rectangles occupy the space of that graph. And you've worked out the total area of the rectangles by figuring out the base and the height of each one using the tables in your calculator. All right, good luck. Have fun. I'll see you tomorrow. Should we bring back FaceTime? Yeah, this is our last. Let's have FaceTime one more time. All right, guys. I think not everybody watched all 3 videos and did all the work. But those of you that did, I will note it'll be pretty obvious tomorrow who met the responsibilities. And I really, really appreciate that you did. It is a big deal to our success that we didn't fall behind. I'm not even lying. Like, if this was a different unit, I might not have done this. But for this unit, for the schedule, for all the stuff, this had to happen, and it means a lot to me. Like, this is why I really do love y'all, is that, like, I already had 40 views on one of the videos, so I already know, like, way before people actually had to go back to school, they were already doing the assignment. It means the world to me. How do you do the hearts? Is that a thing? Is this still a thing? Okay, bye.